Dear students, let us discuss some important, very short answer questions of mechanical properties of fluids. The question is, why liquid drops and bubbles are spherical in nature? So both liquid drops and bubbles, they are spherical in shape because of surface tension. So if you write this, that is enough. So due to surface tension, liquid drops are getting spherical shape. For a given volume of the liquid, sphere has got least surface area. Least surface area. Always a liquid surface tries to gain minimum surface area. So that minimum surface area is possible only in the sphere. Mention any two examples that obey Bernoulli's theorem. Justify them. The best example is a wing of an aeroplane. The shape of the aeroplane is also called aerofoil. Looks like this. This is the shape. So the upper surface is curved. So more air goes through the upper surface and the lower one is flat. So this is called aerofoil. Second is the carburetor of a motorbike or a vehicle. So carburetor. The third one is atomizer or a scent sprayer or any sprayer. Number 4, Magnus effect, or simply you can write the motion of the spinning ball. When water flows through a pipe, it should be pipe, which of the layers moves faster and slowest? So this is a water pipe through which water is flowing. We can consider it as a laminar flow. Laminar flow means water going like layers. When such water enters this pipe, when this enters the pipe, which layer moves fastest? The layer which is in the middle, the center layer moves fastest. So its speed will be very, very high. The next one moves little bit with lesser velocity. This one further less, this one further less, this one further less, and the least one, the slowest one is the layer which is very near to the outer surface, because there will be friction between the outer surface and the water flowing in it. So the middle ones are not having any friction. Friction will be very, very less. So the fastest is the middle one and the slowest is the one which is in contact with the pipe. What are waterproofing agents and water wetting agents? What do they do? This is the question. So if I add soap or detergent to water, it decreases surface tension. What do you mean by wetting agents? So these are the substances which are added to the liquids so that the surface tension decreases. When surface tension decreases, angle of contact also decreases. So what do you mean by wetting agents? These are the substances, when they are mixed with the liquids, they decrease the angle of contact or they decrease surface tension of that liquid. Now what do you mean by waterproofing? Waterproofing are nothing but the substances which are added to the liquids so that they can increase the angle of contact. When angle of contact is increased, that surface is not going to be wet by this liquid. The best example is raincoat fabric. Raincoat fabric. The second one is leaves of the lotus. Leaves of the lotus. That is the reason why the leaves of the lotus are not being wet by the water. If angle of contact is greater than 90 degrees, it is not going to be wet. So such agents are called waterproofing. They do not allow the substance get wet by the liquid. What is the principle behind the working of a carburetor of an automobile? So carburetor is nothing but like a scent sprayer. So there will be a piston, I push it. So what happens? Air moves faster. When air moves faster, according to Bernoulli's principle, air pressure is decreased. In this, some pesticide solution is there or a scent solution is there. Since the pressure is decreased, this will go up and this mixes with air and it is sprinkled. This is the same principle in the case of a sprayer or atomizer or in the case of a carburetor. Simple answer is, what is the principle? The answer is Bernoulli's principle. Bernoulli's theorem is used in the carburetor of an automobile to inject petrol. Define viscosity. What are its units and dimensions? This question is wrong. Why? I will tell you. So viscosity, for example, you consider any fluid. Fluid means it can be liquid as well as gas. So this is called the laminar flow. So water flow can be imagined as the flow of parallel layers. This is called a steady laminar flow. So what happens? There will be a friction between two adjacent layers. So this frictional force acting between the two layers of a gas or a liquid is called viscosity. The frictional force acting between the two layers of a fluid or the force which opposes the relative motion. The frictional force is directly proportional to the area of this layer. It is directly proportional to the velocity gradient. Velocity gradient means velocity divided by distance. So I will put a constant, that is eta, A into delta V by delta X. This is the actual formula. So why this question is wrong? You cannot define unit for viscosity because viscosity is nothing but force. So its answer is Newton. But that is not the question. Here he is intended to ask, what is this eta? This is called coefficient of viscosity. The question must be, what are the units of the coefficient of viscosity? This must be the question. So I am asking the units of eta. So eta units will be, this is force into delta x divided by A into delta velocity. So force units are Newton, distance is meter, area is meter square, velocity is meter per second. So 1 meter and this meter gets cancelled. Newton per meter square is called Pascal. So this is equal to Pascal. So 1 by second comes into the numerator. So Pascal second. This is the SI unit of coefficient of viscosity. In CGS system, this is poise. What is angle of contact? For example, you take a beaker of water and you dip one solid substance, let us say a glass rod. The water surface, this is called meniscus, will be concave surface. Now the angle between this water surface. So how do I measure the angle between the water surface and this solid? That is the glass. So I draw a tangent. This is called a tangent. Tangent drawn at the point of contact of both liquid and solid. So here they are meeting each other. The angle between the tangent drawn at the contact point of both liquid and solid and the solid surface is called angle of contact. You should draw the tangent within the liquid. Give the expression for the excess pressure in a liquid drop and in an air bubble inside the liquid. Here 2-3 questions are there. All the questions can be covered in one way. Suppose you take a liquid drop. So liquid drop, liquid is inside. So how many free surfaces are there? Only one surface. Inside surface is not a free surface. It is filled. In the case of a bubble, you take a soap water bubble. How many free surfaces are there? 2. One free surface, the excess pressure is given by where T is surface tension and R is radius of the bubble. So the excess pressure for one single surface is 2T by R. So for this answer is delta P is equal to 2T by R. Here two surfaces are there, you have to add. So in this case, the excess pressure inside a soap bubble is 2T by R plus 2T by R. So it will be 4T by R. There will be one more question. So there is a water tank. Inside the water tank, there is a bubble. So bubble means inside is empty. So outer surface is not a free surface because it is inside the water. So how many free surfaces are there? Only one surface. So the excess pressure answer is 2T by R. So there are three questions covered in one question. If it is purely a liquid drop, 2T by R. If it is a purely a soap bubble flying in air, the answer is 4T by R. If there is a bubble, air bubble inside liquid like water, the answer is 2T by R.